In this video, we're going to be going through your test review Peardeck that we did in class earlier today. This test is going to be on not only chemical reactions, but stoichiometry. There are 24 questions. It's worth 40 points, but in the gradebook, it will be out of 100%, and you'll have 65 minutes to complete it and link it for it. So let's get started for it. Now, section 1 is all about chemical reactions, and there's going to be 15 questions on the test for it. Now, 13 are multiple choice, and then 2 are going to be drag and drop balancing for it. So, in our first one, let's take a look at what we have. We have PbCl2 aqueous plus 2AgNO3 aqueous yields PbNO3 aqueous and 2AgClS. So what is the state of matter of the second product? So we have to remember that our reactants are going to point to our products. So if we're looking for the second product, we would see it's here. And then when we look at our states of matter, there are going to be those tiny letters behind it. So we would see that the state of matter is S, aka solid. For number 2, we now see what is the coefficient. So remember that the coefficient is going to be that front number that we use for balancing to prove the law of conservation of mass, that our reactants are equal to our products. And we're looking for the second reactant. So our reactants are on this side and our second one's there. So we would see that it is a 2 for that one. So we still have the same equation, but it says, what do we call the solid from a double replacement reaction? Now, we know this is a double replacement reaction because Pb is my A, Cl is my B, Ag is my C, and NO3 is my D. So now I see A with D, and I see C with B. And that's what demonstrates that double replacement reaction. Now, if we're looking for the solid, in this case, that would be the second product of AgCl. Remember, we call it a precipitate. But you can do a process of elimination. You know the yields represents the arrow. The reactant represents our left formulas, and then our product represents those right formulas. Okay, what is the printed subscript for the first reactant? So if we're looking at the printed subscript, we're looking for the tiny number. So let's take a look for our first reactant, and we're going to see the one that's pre-printed is a 2 for that one. Okay, answer the following questions. Fill in the blank. A metal that is blank can replace a metal as long as it is blank than it on the metal activity series. So we have our metal activity series here. A metal that is higher on the list can replace a metal that, as long as it is lower than the metal on the activity series. So the rule is the higher metal can replace the lower can't come up and replace the higher for it. So our first one, let's take a look. We have CD replacing Na. So we find CD, we find Na. Can CD go up and replace Na? That is a big no for that. Now our other one, we have Pb replacing Hg. So we find Pb, we find Hg. Can Pb go down and replace? That is a big yes, it can. Okay, so this one says predict the missing product for the following reaction. So we have Cl is my A, K is my B, and Br is my C. Notice that we now have C by itself. So that means that our A and B have to come together. Now this is a single replacement, but now looking at the non-metal being replaced. So we'll actually see KCl. Now they're not asking you to balance it, but if you had to balance it, you would put a 2 here to balance it out, and then a 2 here for this single replacement. Now, the final one for our chemical reactions, it's asking us to predict the states of matter for the products of this double replacement. So we have Ba and S. So we find barium, we find sulfide, and then we bring it together, and we see that this is going to be S. And remember, it's called our precipitate, aka the solid from this double replacement. Now let's look at the other one. We find K, which is potassium. We find Cl right here, and then we bring them together, and we would see this is AQ, aqueous, meaning dissolved in water for it. Oh, I forgot we have to balance before we move on to stoichiometry. So for this one, we're going to balance it and then tell me what the type is. So we find our arrow, we go down, and we have K, Cl, and O. Then we have K, Cl, and O. So we're going to see K is 1, Cl is 1, O is 3, K is 1, Cl, and 2. Now we're never going to make a 2 look like a 3, but we can make a 3 and 2 both look like 6. So I'm going to put a 2 here. It not only changes my 2 for my O to make it 6, it also changes K and Cl. So I'm going to put a 3 there to make it 6, and then I just have to balance out my K and Cl, and I'll put a 2 here. And then we're all balanced. So the whole goal of adding these coefficients is that we want to see that our reactants are equal to our products. So now let's identify the type. So we have one reactant and we have two products. So we're breaking it down. This one would be an excellent example of a decomposition. We actually have our A, B, and C breaking down into A, B plus C. Okay, let's balance this one too. So find your arrow, draw it down. We have Al, we have H, and O. We have Al, H, and O. So make sure they line up exactly for it. So we have one Al, two H's, and one O. I don't know why I wrote O there. It's Friday. We'll see what happens. Then we have 2, 3, and 2. So let's start with our Al and see how it goes. I'll put a 2 here, that's a 2 there, so we're balanced. Then I have a 2 and a 2, that's awesome already. And then I have a 1 and a 3. So when I put the 3 here, it not only changes the O to 3 to be balanced, it changes this H to be 6. So I go back on this side, I'm going to put a 3 to make it 6, and now we're all balanced. We can put a 1 as our coefficient there. So let's take a look at what type it is. So I have an A plus B and C. Now I have A with C and B's by itself. So this is a great example of a single replacement. We have a single element replacing one in our couple. Okay, section number 2, 9 questions, 5 multiple choice, and 4 drag and drop. Not balancing for this one, it's going to be mole to mole, and then a gram to gram conversion for it on stoichiometry. Okay, which of the following is not the correct mole to mole ratio? And we saw this not only in our doc review, we also saw it as our warm-up last week. So are there 2 moles of hydrogen? Yes. Are there 1 mole of this? So it can't be A. Are there 2 moles of this? No, there's only 1 mole. There's 1 mole, there's 2, can't be that. There's 2 moles and 2 moles, can't be that. So the correct answer of the incorrect mole ratio would be B. Fill in the blank. A coefficient represents the relative mole amount for a compound. So what's the missing piece in red for this mole to mole conversion? How many moles of water, that's my B, could I make if I have 12 moles of O2, which is my A? So this is my A, this is my B. Notice that we have mole of O2. We're going to have mole of O2 there. Just got a little shifted over. So we have to look up at our coefficient. If there's no coefficient, we would say the missing number for this would be 1. Okay, how many moles of cobalt or CO2 will be made from 3.9 moles of O2? So we're going to find O2, and that's going to be my A in blue. So I'm going to have my A here and my A here. Now my unknown is going to be that moles of CO2, which is right here. And we're going to see that this type of reaction is actually going to be a combustion reaction. Now it's a little bit more complex combustion because we have an O in it there. But we'll see that we don't need our first reactant and we don't need our second product. So we get our given of 3.9 mole of O2. Then we look at our coefficient. We're going to have 4 mole of O2 on the bottom, 3 mole of CO2 on the top. And then now we just have to solve for it. So we're going to see if we multiply the top 3.9 times 3, we get 11.7, and then the bottom is 4. So we divide that 11.7 by 4, we get 2.925. So we'll notice that this has 2 sig figs, so 1, 2, will 2 round it up? Nope. So we're going to get 2.9 mole Notice O2 cancels out. We're going to have it for CO2. Okay, our final one. How many grams of Ag can be produced from 11 grams of CO? So we're going to see that we have 11 grams of Cu. So we find Cu. That's going to be my A. And then we find Ag is my grams. That's going to be my B. And then I don't care about these two. So let's start to set it up. So we're going to have our 11G of Cu. So remember, we're going to start with our given first. We're going to go to the periodic table. It's always 1 mole here. We're going to have our Mr. or our mole ratio from our balanced chemical equation. It's always 1 mole here, and then we're going to end by going to our periodic table for it. So if we begin, we're going to see on the periodic table, I hope you have one handy, that it's going to be 63.55 here per 1 mole of Cu. And then we're going to see that there's no number. That's assumed it's going to be 1 mole of Cu here. And then this is where we're going to transition. So we have 2 moles of Ag here for it. Then we're going to have 1 mole of Ag there. So now we need our handy dandy periodic table. So if we find Ag, we're going to have 107.9 grams of Ag. Now we made it to the end, so we're going to cancel out gram, gram, mole, 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 mole. So now hopefully you have your handy dandy calculator ready to go. So we're going to multiply the top. That's 11 times 2 times 107.9. So for the top, I have 237.3.8. And then I'm going to multiply the bottom, which ends up just being 63.55. Oops. And then we're going to divide. So 63.55. And we'll see our answer is 37.35326.515. How many sig figs are in 11? That's 2. So we're going to count over 1, 2. Will 3 round 7 up? Nope. So we're going to have 37 grams of Ag for our final problem going from grams to grams. So hopefully this helps prepare you for your test on Friday on chemical reactions and stoichiometry. Have a wonderful